This meeting is being recorded.
For problem number 25 from chapter 22, we're asked to predict the major product obtained when each of these amines is treated with a mixture of, and this is called sodium nitrite and hydrochloric acid. So what happens when we subject a primary amine versus all three of these will be secondary amines with these reagents is that a primary amine undergoes what's called diazotization. So it will produce a diazonium salt as a product. As opposed to these three products will be through formation of an N-nitrosamine. So we're going to get these N-nitrosamine products, and we'll take a look at the difference between the two. So in this first reaction here in A, we're going to create what's found to be an aryl diazonium salt. So we'll have our benzene ring here in the middle of our structure. Too many carbons there. There we go. And then we have, instead of just a nitrogen with two hydrogens here, we're going to replace that with a triple bond to a nitrogen. So we're going to have a positive charge on that nitrogen there, and then the chloride ion will balance out that charge here. So this is what we're referring to as a diazonium salt, specifically an aryl diazonium salt, which is stable. If we had this process and we tried to produce a primary amine that was an alkyl substituent, an alkyl R group instead of an aryl, the product would be too unstable, that diazonium salt. So that wouldn't work. So we need this aryl or this benzene ring to stabilize this reaction. So again, this will be our final product. So let's take a look at these three secondary amines and see what's different here. So we're going to, again, use the same reagents, the sodium nitrite and HCl. But in this case, where we have the hydrogen here, we're going to insert a nitrogen, and that's going to be bonded to a carbonyl, or rather to a double bond to an oxygen here, to that nitrogen. So we're going to create this N-nitrosamine product here. So again, the only thing that we did was replace that hydrogen with this NO double bond. Let's take a look at compound C. This is also a secondary amine. So once again, that nitrogen will be bonded to another nitrogen here, and that will be doubly bonded to an oxygen. So again, this is a secondary amine. When we react that with our sodium nitrite plus HCl, we're going to get that N-nitrosamine product. All right, this last one here, again, we're going to replace that hydrogen with a bond to a nitrogen and then a double bond to oxygen. So nothing happens to the ring structure here in this bicyclic compound, but we do produce from a secondary amine an N-nitrosamine.